In this video, I'm going to solve this differential equation. By looking at this, it kind of looks like an exact differential equation that has the format p of x comma y times d of dx plus q of x comma y dy is equal to 0. If we compare these two equations, we see that this is my p of x comma y and this is my q of x comma y. Now to solve this differential equation, we kind of have to show that it is in essence an exact differential equation. For a differential equation to be an exact differential equation, you have to have these conditions satisfied. Partial derivative of p with respect to y must be equal to partial derivative of q with respect to x. And let me quickly check it. So del p over del y is equal to del y of 3x square plus 2y square. Okay, and if you take the derivative, this is going to yield 0 because 3x square is a constant when you are taking derivative with respect to y, and the derivative of 2y square with respect to y is nothing but 4y. Now let's find del q over del x, which is very easy. That is del over del x. Q of xy is 4xy, so it's going to be 4xy. And the derivative of this is going to be just 4y. So in essence, we found that these two are equal, right? So this 4y ensures that del p over del y is equal to del q over del x. So that tells me that this equation, differential equation that we are dealing with, it is an exact differential equation. That also tells me that there is a function which we call potential function. Actually in physics they call it potential function. Del f of x comma y is equal to some constant c. So that's going to be the general solution to this differential equation. Now, if that is the case, can we find this function, potential function? Yes, of course we can find it. By definition, we know that del f over del x is nothing but p of x comma y. Now, if I integrate both sides of it, so I'm going to have integral p of x comma y, I'm going to integrate with respect to x, must be equal to integral del f over del x dx, and that has to be equal to the original function, that is f of x comma y. Now if I rewrite this further, so it's going to be f of x comma y is equal to integral of p of xy. P of xy is this guy, which is going to be 3x square plus 2y square, and I'm going to integrate it with respect to x. Is going to give me f of x comma y is equal to integral of 3x square with respect to x is 3 times x cube over 3 times x cube over 3 plus 2y square times 2y square are going to be constants, right? So integral of dx is going to be just x. Then we have to add an arbitrary sort of like constant, which is actually a function. Is going to be a function of y that kind of serves as a constant because we are integrating with respect to x. Now if I rewrite it, I'm going to get f of x comma y is equal to 3 cancel out. That's going to give me x cube plus this is going to give me 2x y square plus g of y. Now, in theory, we found a function, right, f of x comma y. However, we still do not know what is g of y. Can we find this? The answer is yes, because q of xy, by the way, is nothing but del f over del y. So if I take this function and take partial derivative with respect to y, that has to be equal to q of xy, which is 4xy. So del f over del y is equal to, so derivative of x cube with respect to y is 0. Derivative of this thing is going to be 4xy, right? Derivative of y square is 2y plus g prime of y, because g is not an explicit function, it's just a function at this point. And that is, so that must be equal to q of xy, which is 4xy. So you have a 4xy here, 4xy here. If you subtract it from both sides, you're going to get g prime of y is equal to constant. And that constant is 0. Now, if you integrate it, integrate g prime of y, okay? So that's going to give you g prime of y dy is going to be just g of y, right? That g of y must have to be some constant because derivative of g of y is 0, right? So this is some constant k. Now if I take this value and plug it in here, I get f of x comma y is equal to x cube plus 2xy square plus some constant. But technically this is supposed to be equal to another constant, right? So we could just combine these two constants and come up with a single constant. So f of x comma y is equal to x cube plus 2x times y square, that is equal to some arbitrary constant c. So this is in essence your solution to the given differential equation. I hope that this discussion was helpful. Thank you very much.